वक्त आप लोगों का ये होगा कंप्लीट।
तेरा जिंदगी कुछ नहीं होगा तो
ये चूतिए चुप रहे भोसड़ी के।
आंसर
In this question, we are given a quadratic equation which is ax square plus b minus 4 into x plus a plus 1 is equal to 0. And we are asked to find out the number of integral values of a for which both of these roots are greater than 0. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0. Now, for the roots of this quadratic equation to be real, the discriminant has to be greater than or equal to 0. What is the discriminant? The discriminant for any quadratic equation is b square minus 4ac, where b is the coefficient of x, a is the coefficient of x square, and c is the constant term. Similarly, if you have both the roots to be positive, then the product of the roots has to be positive. What is the product of the roots? That is c by a has to be positive, and the sum of the roots also has to be positive. What is the sum of the roots? That is minus b by a. This also has to be positive. So in this particular case, we will check for all the three conditions. The given quadratic equation is ax square plus a minus 4 into x plus a plus 1 is equal to 0. What is the product of the roots of this quadratic equation? It is the constant term divided by the coefficient of x square. So a plus 1 divided by a has to be greater than 0. If you multiply the left hand side and right hand side with a square to remove the fraction in the denominator, it will become equal to a into a plus 1 is greater than 0, or the value of a has to be either greater than 0 or a has to be less than minus 1. This is the first condition. This is if the product of the roots has to be greater than 0. Next, you want the sum also of both the roots to be greater than 0. What is the sum of the roots of the given quadratic equation? That is minus b by a, where b is the coefficient of x. Here the coefficient of x is a minus 4. So minus of b will be 4 minus a divided by the coefficient of x square, which is equal to a. So 4 minus a divided by a again has to be greater than 0. So let us again multiply the left hand side and right hand side with a square. So this becomes equal to a into 4 minus a. This has to be greater than 0. If you multiply the left hand side and right hand side with minus 1, as it is less than 0, the sign of the inequality will change. So this will become equal to a into a minus 4 is less than 0, or the value of a will lie between 0 and 4. So a has to be greater than 0 and a has to be less than 4. As a is an integral value, the only possibilities are a is either 1 or 2 or 3. Now let us look at the last condition. The last condition is that you want the discriminant to be greater than 0. For the given quadratic equation, what is the discriminant? That is b square minus 4ac. So that is the coefficient of x whole square. So this is a minus 4 whole square. Should be greater than or equal to 4 times the coefficient of x square, which is a, into the constant term, which is a plus 1. Or a square minus 8a plus 16 has to be greater than or equal to 4a square plus 4a. Or 3a square plus 12a has to be less than or equal to 16. You can take 3a common, so this is 3a into a plus 4 has to be less than or equal to 16. The value of a the values that a can take are only 1, 2 or 3. In case of 1, the value of 3a into a plus 4 will be equal to 3 into 1 plus 4, that is 5, which is 15. So this is less than or equal to 16. So a is equal to 1 is a solution. If you are looking at a is equal to 2, the value of 3a will be equal to 3 into 2, and a plus 4 will be equal to 6. This is equal to 36, which is strictly greater than 16. So a cannot equal to. Similarly, when you are making a to be equal to 3, this will be equal to 3 into 3 into a plus 4, that is equal to 7. This also is strictly greater than 16, so this also will not hold true. So the only integral value of a for which all the three conditions are satisfied is if a is equal to 1. So you have one integral solution.
यार से मरे तो कुछ नहीं मैंने तो की रिकॉर्डिंग करनी रखा तो तू